my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about question bank discussion on basic morphological algorithms. So first question, explain the following morphological algorithms and boundary extraction and hole filling. It is the first question in the question bank of module 5. So before going to this question, first we have to know about the morphological algorithms. Then we can go for the boundary extraction, then hole filling. So first one is a morphological algorithm. Basic morphological algorithms are applications. The principal application of morphology is extracting image components that are useful in the representation and description of shape. Morphological algorithms are used for boundaries extraction and skeletonization, that is extracting the skeleton of an object and thinning. So boundary extraction, what is the formula for boundary extraction? So it is, first I am taking a value set A, it is denoted by beta of A, it can be obtained by beta of A equal to A minus of A. It is a dilation, it is a erosion and dilation symbol, where B is the structuring element. A equal to image, B is the structural element. So the boundary of a set A denoted by beta of A can be obtained by beta of A equal to A minus of A, erosion or dilation B. But B is the structuring element. But what is the morphological algorithms? The principal application of morphology is extracting image component that are useful in the representation and description of shape. So morphological algorithms are used for boundaries extraction. So what are the images of there? We are going for the boundary extractions of that margin. So if I am taking f of x comma y, so what are the boundaries are there? 0 comma 1, 1 comma minus 1 or 1 comma 0, like this. So these morphological algorithms are used for boundary extraction and skeletonization, that is extracting the skeleton of an object and thinning. So what are the morphological operations? Neighborhood operation carried out in spatial domain based on mathematical morphology, set theoretical framework originally for binary images, extended for grayscale images. What are the applications which extract information about forms and structures, shaping and filtering of forms and structures. So before going to these morphological applications, so these morphological are using for the boundary conditions of the image x and y. So the neighborhood operations carried out in spatial domain based on mathematical morphology, the theoretical frameworks are to be framed, and original of binary images. What are the binary images? We have to take that one like this, and extended for grayscale images. What are the applications which extract information about forms and structures, shaping and filtering of forms and structures? So morphological processing consisting of essential of two steps: probability of given object in x of m comma n with a structuring element SE, and if I am taking the any of the image, that is x of m comma n and structuring element, definitely these two we need. So x of m comma n and a structuring element, and the structuring element fits the object. What is the object? So if I am taking what is the object, we have to apply the structuring element to the object to find out the foreground and background in object in binary mode. And the information about fit is used to extract information about the form of object or change pixel values and shape objects. Different size and shape of structure element yields different kinds of information about the object, shapes of regions in different ways. So these are the morphological processings. In the previous we discussed applications, but here morphological process, how the process is going on. It is a two steps. First one is a image is x of m comma n, the object, and we will apply the structure element as SC on the original image and fit the object on the image. The information about fit is to be used, extract the information about to form the object or change pixel values and shape objects. Different size and shape of structure element yields different kinds of information about the object and shapes the region in different ways. So some basic morphological algorithms. First one is a boundary extraction, region filling, extraction of connecting components, convex hull, thinning, thickening, skeletons, and rounding. So these are the morphological algorithms. So everything we need about this one, but different morphological algorithms are using for different applications. Suppose for boundary extraction, I am using one thing. Suppose I go going for the image regions. What are the regions? Suppose I have to go for the extracting the image. So and another one is a thinning and thickening. So different applications of the image we are using, different algorithms are using. So these are the basic morphological algorithms. So boundary extraction, region filling, extraction of connected components, convex hull, thinning, thickening, skeletons, and pruning. So boundary extraction. First, in this one, first we have to go for the boundary extraction. First one we will discuss now. So boundary extraction. It is the erosion of A by B. Erosion means already we know that A, erosion B. Then make set difference between A and the erosion of B. Thickness of the continuer depends on the size of the structuring element. So already we know that the beta is a boundary extracting value. Beta of A equal to A minus of A eroded B. So here beta is a extracting value. How much we are extracting, that will be depending on original image with A erosion B. What is the result? That is the beta of A, this value. So suppose here I am taking the image is A and the structure element is B. Here A erosion B. Here it is a extracted output. So extracted output is depends on original image with structuring element, A minus of structuring element of this one, and the final value is eroded. How much? What is the eroded value? This one is equal to the extracted output. Here figure A is the set A, that means original image. Figure B is the structuring element, and C is the A eroded by B, and D is the boundary given by the set difference between A and its erosion. So boundary extraction is the A erosion of B, then make set difference between A and then erosion of B, and the thickness of the continuous depends on the size of the structuring element B. So total extracted value is the beta of A equal to A minus of A eroded B. Here it is one example of boundary extraction. Here we can observe here it is a figure A, figure B, and a figure C. Figure A, the object in white, background is black. So object is in white, background is in black color. Here same thing is there, but we are extracting the object, means exact shape. Extracting the image, that means exact shape, and what are the boundaries are there, these boundaries I am taking as a black color. Here the boundaries are not in black color, the total image in white, the total object is in white. But here what is means boundaries are in black. Here boundaries are white, remaining in black. So we can observe here the boundary extraction. In this boundary extraction, I am taking the image with structure element, and I am applied the erosion option. Here also boundary extraction. First image is the original image. The image completely object is in white, background is in black. But when I am going to the second one, the boundaries are black, the object is white, and boundaries are black. So here after then it is completely black, only the boundaries are white. So that is the extracting the boundaries. That is advantage of morphology of boundary extraction. It is the another example, a simple binary image with S representations of white, result of using with the structuring element in this one. So it is having figure A and figure B. The illustration of with 3x3 structuring, the element of ones for all boundaries images in the chapter. Binary ones are showing as a white one. It is a 0 equal to black. So here object equal to, what is the color object? White. So I am taking as a 1. Background equal to black. Background, what is the background here? 0. That means black. But here all are black. All are black. That means 0. Except boundaries. Except object boundary. So it is the 3x3 structuring element of ones of binary images, and ones are shown in a white and zeros are in black. So the elements of the structuring element which are ones are also treated as white because of the size of the structuring element used, and the boundaries are is in 1 pixel thick. So boundaries are in white, remaining are black. In the first image only the object is showing as a black white, remaining are in the black. It is also one example of morphological algorithm. Another is a second sub question, hole filling or region filling. This algorithm is based on a set of dilations, completations and insertions. P is a point inside the boundary with the value of 1. Xk equal to xk minus 1b, conjunction with complemented A. The process stops with xk equal to xk minus 1. The result that given by union of A and xk, that is xk ua, is set of contents of the filter set of the boundary. So I am taking as a whole region filling. It is a dilation. In the previous we discussed erosion. Here dilation process. P is the point inside the boundary with the value of 1. Xk equal to xk minus 1b, conjunction with complemented A. The process stops when xk equal to xk minus 1. The result that given by union of A and xk is set of contains the filling in the set of boundaries. Okay, that is a region filling. Here example of region filling. Figure is a binary image. Figure B is the object boundary extracted using previous question with the 3x3 structuring element. It is a 3x3 structuring element. It is the output image with the boundaries. So here the object is in white, background is in black, but here only borders are there. What are the borders are there? It is only white, remaining all in black. So here exact sharpening of the object face. What is the object? These borders are sharpened. It is the whole filling or region filling of this one. So the size of the boundary element 3x3 pixel. The resultant boundary is 1 pixel thick. The 5x5 structuring element will produce boundaries between 2 and 3 pixels thick as shown in the next figure. So here 3 types of figures are there. Figure A, B, C. A is the input, B is the output, and middle one is the structuring element. It is the structuring element. It is the input image, output image. So at the output, we are sharpened the object boundaries and filled with black color of image. So the size of the structuring element is I am taking as a 3, and here 5x5 structuring element is changed to the boundaries. So 3x3 converted to the 5x5. Okay, then exact sharpening of the image, exact looking is good comparing to the 3x3 structuring element compared with 5x5 structuring element. So what are the operations performed by segmentation? Image segmentation is a technique by which a digital image is partitioned into various image objects. Each of the pixels in a region image object is similar, consisting of subproperty such as color, intensity, location, or texture, which can reduce the complexity of the image for easier analysis. The hidden information is also detected from the image with the help of segmentation. So, segmentation algorithms work on the two basis properties of image: intensity values such as discontinuity and similarity. Discontinuity is one thing, similarity is another one. So, what are the operations performed by the segmentation? So, image segmentation is a technique by which a digital image is partitioned into various image objects. Each of the pixel in a region image object is similar, concerning some property such as color, intensity, location. Already we know that HSI, color, hue, saturation, and intensity. Like this, I'm taking as a color, intensity, and location or texture, which can reduce complexity of the image or easier. The hidden information is also detected from the images with the help of segmentation. So segment algorithms work on two basis properties: intensity value such as discontinuity, another one is similarity. The name of intensity is the boundary approach. The name of similarity is the region approach. So boundary approach and region approach, two are the basic major types of operations are there in the segmentation. So what is the need of image segmentation? Partitioning image into different objects, fetching information from it, and then labeling are used to train various ML models to address the business problems. One example would be a facial recognition system for marking attendance automatically with the help of segmentation. Another application of segmentation is in the medical field for efficient and faster diagnosis after detecting severe diseases like tumors, cancer, etc. Also for seeing the patterns in medical imagery generated by radiography, MRI, thermography, endoscopy, ultrasonography of cells and tissues. Okay, so these are the needs. Once again, we can see these are what are the needs of image segmentation. So, suppose there are different segments are there in the image. So, how many segments are there, and what is the shape of the segment? So, image segmentations are majorly used in medical field and to finding out the facial recognition or iris of the image. So, gestures of the image. So, partitioning an image into different image objects, fetching information from it, and then labeled are used to train various machine learning models to address business problems. For example, facial recognition is a system for marking attendance automatically with the help of segmentation. Another application of segmentation is the medical field for efficient and faster diagnosis after detecting severe diseases like tumors, cancer, and also for seeing patterns of medical imagery generated by radiography, MRI, thermography, endoscopy, ultrasonography of cells and tissues. So majorly segmentations are using for facial recognition and medical field. Image segmentation has huge applications in areas like robotics as well. Image classification is one of the popular applications of segmentation, where an algorithm is able to capture only the required components from an image. So implementation of image segmentation is Python too easy to perform in order to get the fast results. So face recognition, medical applications, robotics, machine learning, and the popular applications of segmentation will capture on the required components of the image. So components finding, components capturing, etc. To implementing the image segmentation, the Python using to perform the get faster results. So these are the applications of image segmentation. Image segmentations are majorly three types: edge-based technique, region-based technique, threshold-based technique. And what are the advantages of edge-based is works well when the edge is prominent. What is a disadvantage means could not be applied on images having many edges, not suitable for images having smooth edges. Region-based technique means advantages better for noisy images where edges are hard to identify. Disadvantages is that to point must be specified. Different seed points may give different outputs. Thresholding technique. We know that what is the threshold level of this one. Okay, it is a threshold level. So advantages is one of the best is the easiest technique is that, and the disadvantages could not be applied on images having complex intensity distributions like medical images. Cannot process the images whose histograms are nearly unimodal. Segmentations are based on discontinuity and based on similarity, edge-based, threshold-based, region-based, and spatial theory, neural network-based, clustering-based, value-based. So these are the image segmentation techniques. Explain the following morphological: boundary extraction and hole filling. Morphological operations: boundary extraction, hole filling. It is one question. Operations performed in segmentation. There are two types are there: intensity and similarity. It is a need of a segmentation, types of image segmentations, segmentation methods. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.